All right, we are live. Welcome in, welcome in. Tonight is all about hot rod electrical work. We have been hard at it in the Discord talking about the project, designing a car from scratch, but this is what I do to make ends meet in the meantime, since we don't have a car factory producing cars that we can sell and provide a living for everybody. So I fix them to get by. So this project behind me has been a great source of fun for me. I really enjoy doing this wiring harness. I've never made a wiring harness from scratch before, so it's quite fun. It really lets me zone in and just get hyper focused on trying to make it nice as possible, which is something I really enjoy. I could really put my energy behind it. So I know for a lot of people, wiring is kind of a pain in the butt. It's really tedious. You have to have a lot of patience for it. There's really just no alternative. You just have to sit down, put a lot of time aside, double that time that you think you have to put aside, and then maybe double that one more time just to ensure that you definitely have enough time to do your wiring job. But if you are patient with it and you don't cut corners and you don't put freaking wire nuts on your car, which should be illegal. You should go to jail. If you put a wire nut on your car, just straight to jail. If you don't do that, you can end up with something really nice that you're proud of. So I'm just going to share some experiences that I've had as I'm learning how to do this. And let me switch tabs so I can see if there's any comments coming in. I'm on a laptop right now. So just trying to be creative so that I can see the comments and be able to do what I have to do to the video feed at the same time I'm presenting this to you. So have a little chat window here on the, what side would that be on? I don't know, the mirror thing throws me off sometimes. We have a chat window so that when this video is completed, we can see the questions and comments that people are asking as we go along. So let's get right into it. What I did when I started out was I just went through the car. And actually, before I go there, let me start with why you might want to do this, why you might want to make a custom wiring harness for your car. Crumbly wires, old 50, 60-year-old crumbly wires that are faded and oxidized and about to start a fire. Replacing those is probably a good idea. Probably a good reason to do a custom wiring harness if you have a lot of that wire damage going on in your car. And then there's a few more reasons specific to this particular car. We went to a fuel injection system, so we have a little bit of a custom harness going on there. That doesn't necessarily necessitate the need for a full custom harness because it does come with what you need to build it into your existing harness. And it works. You have, let's see here. That's not from it. One sec. One of the things the kit gives you is this fuse holder, so you have to find a place to screw the fuse holder into your firewall or your fender well or something like that. And then there's also a relay plug. It's similar to this. It's not this exact one. But you have another plug that holds a relay and that also has a tab and a hole in it where you got to screw these somewhere. And it works, but it's kind of ugly, right? It doesn't look very good. So in the process of replacing all the other wires, I've kind of put everything together so that all the relays can be in one place, all the fuses can be in one place. We eliminated this inline junk, and it's all going to be coming off of here. I'm going to put a link in the description to all of the Amazon purchased items that I used in this kit. And they're not there yet, so give me maybe an hour or two after the video is published. If you're watching it live and you want to see the items that I used in there, I'll put those in there so you can see for yourself if you have a project like this you're taking on. This is from Haltech. It's a 6-circuit unit, and it's the perfect amount of circuits for a hot rod. You don't need more than that. Some of the things, like the switches, for instance, on a hot rod like this, they're really burly. Like the switch acts as the relay because those contacts inside there can take a lot of cycles. They can take a lot of abuse. So you don't find a whole lot of relays on an old car. It's better if you have them because the switch does last longer if you put it on a relay. Yeah, you can sort of get by with just your major components on your relay box, and you don't have to fully rely on them maybe as much as a modern car. So we integrated the fuel pump relay that came with the Holley Sniper system into here, and then also the fuse that goes along with it. The instructions from Holley recommend that you take the battery wire right from the Holley unit and go straight to the positive terminal of the battery with it. I did that in the beginning before I did all this work when the car was still running, and it completely drained the battery. There was some, I don't know if there was a faulty part somewhere inside the unit. I did narrow it down to something within the unit itself that was pulling a load. So despite them having said to do that, I definitely recommend putting it on a ignition relay so that it only gets power when the key is on. It's the only time you need it on anyways. So those are the reasons why you might rewire a car, and this is how I started. So I just went through kind of from the back of the vehicle up to the front, labeling everything that I could see, what kind of connection did it use, whether I was going to completely, that's a different page, whether I was going to completely replace both the male and female side of the connector, or if one of the sides was going to be retained, and I was going to try to match it on the other side if there was an available part online that would link up to it. So started at the end, made all the colors, how many connectors I might need, what shape they were, how long they were, and the color. I think I already said that. And then I worked my way up to the front, and I think I did, yeah. And then I did a separate one for the engine bay because I was running out of space on the piece of paper. So I purchased all the wire from Rock Auto. Got an excellent deal on it. They were having like a closeout sale. So we got all the wire for like 8 cents a foot, 14 gauge wire. I just got all 14 gauge wire because there's only a couple things that need to be thicker than that. And it's thicker than I need for most things, but the price was so good, it just didn't make sense to get anything else. So we got 8 different colors, 100-foot roll each, and they were only $8 a roll. It was, yeah, super awesome price. So it's a little bit less colors than there are circuits in the whole vehicle. So the same color is going to be reused a couple times here and there. So because of that, I also got a roll of heat shrink tubing that's printable with one of these label printers. This is something I got on Amazon. I think it was like $50, and really worth it for, you know, keeping things sanitary with this label stuff. Did have an issue with it. Let's see how well you can see that. If you see the 2 little dots there, everything above those dots is wasted material. So if you are using one of these, let's see, I'll show you another piece too. Printed horizontal that way. This is the way I was printing most of them, so it's easier to read. Everything above those dots is wasted material, so it benefits you if you can kind of print all the labels you need to, so that you only have 1 inch wasted material rather than 1 inch per label, because I went through this entire roll of heat shrink really quickly because I was trying to figure out how to make it not waste 1 inch of tape for every print move, but there's no way to. It needs to feed that amount through for all the different layers that are inside the tape to come together and produce the printed piece. So yeah, if you want to save tape, make it last as long as possible, print all your labels at once. So Mark's asking me here, do I use copper wire or copper-clad aluminum? We used, most of it is pure copper, and some of it's tinned copper. I don't believe anything is aluminum. I try to be real careful about that. Some of the stuff you get from Amazon, a lot of the wiring you get from Amazon is aluminum. So you want to be careful. Aluminum only has 60% of the conductivity that copper does. So it really affects your gauge thickness. If you do go with an aluminum wire, you need a lot thicker wire. So if you're expecting the same amp rating out of the same diameter of aluminum, could cause the potential for a fire. So yeah, unless it's for something that doesn't have a high continuous rating, like sound systems. Normally they don't have a very large continuous power draw. I think that's really the main use case for the aluminum wire, as it is cheaper. But if you're using it for anything that's gonna draw a lot of power, definitely go copper. So something I wanted to share with you guys was, let's see, here it is. Most of the terminals that I got fit within a, let's see, like a connector system like this. It's old school. I wanted to get stuff that would match up to what the car already has as much as possible. And then when that's not possible, I got a like a knockoff Deutsch connector kit for the connectors that I was going to do, from scratch. But for stuff like this, you need a open barrel terminal, such as this. And from what I could tell online, this uses a crimper, like something like this. It's got a ratcheting mechanism. You can kind of like sneak up on it. If you can't quite get a grip, it holds its position, and then you can go back in and click it again. That's what I thought I needed, and I thought I already had for these open barrel terminals. The problem is the profile on the jaws themselves were not right. They don't squish it. What you need is something with like a W shape inside the jaws, which I'll share with you in the description. But these don't cut it. So I was ready to cut wires and start pinching a bunch of terminals on them, and I didn't have the right tool. So I went online, tried as I might to find something local where I could buy the right tool, but that didn't work. I didn't find anything local. I bought one on Amazon to come in the next few days. It's still not here, actually. But I had to figure out a way to pinch these together safely with the wrong tool, because I wasn't about to change the course of my day because I didn't have the right tools. So I wanted to share with you guys how I did that. So let's get a wire stripped here. Definitely get a pair of strippers like these. Just don't even mess around with it. Like, you're going to be stripping wires a million times. You want it to be quick and easy. So strip your wire, get it so it goes past the tabs a little bit, so it gets a nice good crimp. And then what I'm going to do is I'm going to fold one of these tabs over slightly with a very small pair of pliers. The smaller the better. Really helps you to get the control that you need to fold this over. So we're going to first fold it like that, so it's halfway covering it. And then you want to kind of come in at a 90 and try to squish it straight down as much as possible. So now it's like fully over on one side. And then at that point, it's really easy to bring it back over on the other side. So now you have something that's overlapped pretty well flat. Similar thing with the bottom portion of the wire, although this side's not as important. It kind of just hugs the wire. It's not your main electrical connection. Fold that over the same way you did on the top. Bring it in. Fold it over. Bring it in again. At this point, you get your standard crimpers. Take the overlapped portion and put that on the non-protruding side of the crimper, and then just let it bite down. It's crimped just as well as any non-insulated terminal would be. Perfectly safe. It's not going to pull out. I think probably just as good as what the real tool would do, although this takes a lot longer. But you can make these work if this is the only tool you have. As far as measuring wires goes, I measured this wire just with my hand from the spool. And this is about 1 foot exactly. And I took it just to see how close I was going to be with a ruler. And it's within like 1/8 of an inch, dude. So if you're measuring, 12 feet of wire, don't bother using a tape measure. Don't bother using if I can learn how to talk, don't bother using a ruler. Just use your hands, thumbs extended, knuckles extended. That's a foot. It's as close as you ever need to be, especially for wiring. Cool little trick for measuring stuff. So let's talk about something a little more interesting. The car originally came with a hydraulic convertible top opening system, and the owner was concerned that if it failed, it could potentially leak all over his new carpet. The carpet hasn't been installed yet, but he's had a lot of issues with the hydraulic system in the past, particularly the pump, and he was just really, really wanting to ensure that if anything went wrong, it wasn't going to ruin the carpet. He didn't care so much about the function of the convertible top as much as he cared about having to redo a bunch of carpet work on the inside of the car. So I thought about it, and I worked on the hydraulic system a little bit until the pump failed. It got too hot, and it like spit the O-ring out, sprayed fluid all over the inside of the car. Not carpeted, thankfully. He got pretty pissed off at that point. Said, we'll just leave it manual. He's like, I'm done with the hydraulic system. We'll leave it manual, and we'll just forget about it. So it came to mind that they make linear actuators that are purely electric. So I recommended that to him. Seemed pretty happy about the idea. So that's what I'm going to put in the back: 2 linear actuators, 1 on each side. There'll be no hydraulic fluid. If anything happens, the carpet's good. So I wanted to get the actuator that could handle the most load as possible, thinking that the higher load rated actuators were higher amp rated motors. But that's not the case. What they do, if you go on Amazon and you look for a linear actuator, you have various levels of weight that they can handle. And the higher weight actuators, they just move slower because they have a greater mechanical advantage. The amp draw is virtually the same for a 1,000-pound actuator. I don't remember all the exact sizes, but just say the 1,000-pound actuator versus a 100-pound actuator. They all use the same motor. It's just the 1,000 pounds moves 10 times slower. So originally I thought it was going to be like a nice big, 8-amp motor or 10-amp motor or something like that. And I was going to run a fat cable to the back and then split and then have a separate relay system in the rear and have that completely isolated from my main relay box. But the amp draw is not even really that much, so it's going to be totally overkill. I bought an 8-gauge wire to go back there, which will be far more than necessary. But it did teach me that it's better to get the lightest weight actuator as possible because it's going to move the fastest as long as it is strong enough to lift up the rated weight. So that's the direction we went. That stuff hasn't arrived yet. I was going to show you kind of what I was going to do to it. As long as the stroke is as long as it needs to be, I was going to modify it so that the overall length is what it needed to be to reach the pivot points inside the car, but I can't do that because they're not here. So the other thing, that's what I was gonna show you. Here we go, relay polarity. So this is how you would wire the relays to be able to reverse the polarity on the motor when they went back there. So if you have a situation where you need, you're doing a custom wiring harness, you need a motor to be able to turn 2 different ways, you can use 2 5-pin relays wired in this configuration to do the reverse polarity switching. And from what I can tell, any electrical engineers correct me if I'm wrong, from what I can tell, it looks like the load is carried equally by both relays while the motor is in operation. But as you can see, when both relays are not engaged, you have positive at both terminals of the motor. So it's not doing anything. There's no load. And then if one of these is on, it completes the circuit, the motor turns, that one turns off, the other relay activates, completes the circuit, and it turns the other way. So super simple. What this doesn't show is the place where the relay actuates. You know, it's missing 2 pins, but it's pretty self-explanatory. The place where the relay actuates, you put hot on one side and ground on the other, and then it goes closed or open, or however the relay is designed. So that's what we're working with there. And then one of the other things we did here was switched from a points-based electronic ignition system, we switched from a points-based ignition system to an electronic ignition system. There are different solutions for different cars as it pertains to this. There's a kit for the Dodge that uses a special pickup, and it just directly converts the distributor to an electronic ignition. You don't need a separate ignition module. You just put this, it's called a Pertronics is the name of the company that makes it. You put a Pertronics unit in there. It has a strong inductance, I guess. So as the distributor turns, it gives enough voltage to the coil to excite it to make the coil do what it's supposed to do and raise the voltage and send it to the plugs. So that failed during the course of the ECU problem when it drained the battery. So the replacement for another one of those Pertronics units that converted the distributor was the same cost as a brand new distributor that was designed for electronic ignition. So I just bought the whole distributor instead of the Pertronics unit because it's designed better because it's made for that setup. The problem is the pickup on a regular electronic ignition distributor is too weak to send enough voltage to the coil to make the coil do what it's supposed to do. And it needs an ignition module in order to make it work. So it was a really simple solution, thankfully. You install a Chevy HEI module linked up to the distributor, and that takes care of everything. Dodge makes their own ignition module that came with the car new, that matched the year of the distributor that I got. But it was so much easier and more reliable to go with the Chevy HEI system. So you wire it the way that it's shown here on the screen. You have one going to your battery source, which everyone recommends be as thick of a gauge as possible. Some people say don't even relay it, don't even put a fuse on it. But it's always a good idea to do that as long as everything's big enough. It's claimed that they surge when you start it, so you sometimes need a pretty big fuse. Yeah, I haven't noticed an issue with let's see, I don't remember what was on it before, but I'll let you know after I put a 20 amp fuse on it if it blows or not. So that was that on the HEI system. Wait, here we go. Hiding the wrong stuff. Cool. So yeah, that's most of the philosophy of it. What can we do next? I don't know if there's enough of you in the comments or enough of you watching to have a question for me in the comments that you want answered. If you do, feel free to throw it in there and I'll be happy to answer. And in the meantime, let's see. In the meantime, show you how these Deutsch connectors go together. So these are like the Chinese knockoff ones. They're not from Germany, I don't believe, based on the broken English on the package. But what's really cool about them is these custom crimpers that crimp from 4 directions at once. If you do go for the Deutsch style connectors, definitely go for the closed barrel pins, because these are much more secure. They do also sell these in an open barrel style, similar to what I showed you earlier, how to crimp these the wrong way. But they're not nearly as good as the closed style. But the only way to crimp the closed style is with a set of crimpers like these. So you just crimp the other end of this. I already lost the pin. There it is. Get your wire in there. Kind of get it right to the edge is the way I've been doing it. It's been working out well. Same thing with these. It has a ratcheting mechanism, so it locks itself in place until you're done. Releases and get a nice secure crimp. That goes through this rubber portion, has a nice weather-tight seal, I do believe. And yeah, it locks in. The best thing about Deutsch-style connectors, if you've never used them before, the very best thing about them is how easy it is to get the pins in and out. If you make a mistake, all you need is a really small screwdriver. And the little tab, if you've ever pulled a regular pin, you know that, let's see, I don't have one right here. Here's a good example. You have these little flares on the side that you have to push down, and then if you want to reuse it, you have to kind of like pry it back out again so it'll click the same way when it goes back in. These are not that way. You get in there, you release the plastic tab, it comes out and goes, right back in wherever it actually needs to be, without having to bend it back into shape or anything like that. So yeah, they're really nice for being able to service and replace the pins and move them around as needed. Cool. All right. Let's put that back. Okay. What else should I go over with this? The amp meter. Let me show you how that thing works. So rather than show the total system voltage, which is an effective way of knowing how well your alternator is charging the battery, the old school way to do it is to actually measure the amp draw. So you need a full-sized alternator cable going directly to the amp meter, because the full charging energy of the alternator is going right through this gauge. And that's how it works. That's how it shows you if you're drawing more power than the alternator can provide. In which case it'll fall down and show you your battery's not charging. So while the hydraulic pump is on, and also the headlights and the fuel pump, in this case, not with the original one, but with the electronic fuel pump, maybe if all that's on at the same time, it's not going to be charging the battery, and you'll see that reflected here. So since I didn't want to go to a more modern setup, I wanted to leave as much old school and original as possible on this car. But I also wanted to clean up the way that the wires entered the firewall. I got a couple of these plugs. So these will be in the firewall. We'll be able to safely send a lot of current through them without worrying about whether it's going to short out, rub its way through a grommet or anything like that. These are from Summit Racing. They're about $10 each. And yeah, we'll have two in the firewall for the in and the out, basically just for this amp meter. But it'll also give us a post on the inside of the firewall, one of which I was going to run to the linear actuators in the back. So that's how that goes together. What could I demonstrate for you guys? Yeah. On the HEI modules, you always want to make sure that you have your heatsink paste that goes between the back of it and preferably good conducting metal that it gets screwed into. Aluminum works well, or copper, which would be kind of weird and unusual. Aluminum does the job pretty well. This is the same stuff that you would use on a CPU for a computer when you're putting a heatsink on it, which is where I had this stuff left over from. The HEI module puts out a lot of heat, so having this stuff between it and the aluminum helps to ensure that there's no hot spots being generated that'll reduce the life of the HEI system. So with that, I don't specifically have another thing prepared. Will I be wrapping the wire loom? I will. Not in a very nice way. I'm going to use the standard corrugated stuff. I know there's nicer options out there, but I tend to, like when I'm putting, hopefully anyone watching has experienced it as well. I'll have a wire here, and I'll have the heat shrink cut, and I'll have the connector and everything ready to go. I keep reminding myself, I'm like, all right, heat shrink, connector, crimp. Heat shrink, connector, crimp. In what order to put it on. Because once you put the connector on, usually the heat shrink's too small to go over the whole thing. Or especially if you have like 2 or 3 wires that you're putting together. And inevitably, I crimp before I put the heat shrink on. And I have to cut it off, or depending on where it is, I can't, and then I have to wrap it with, self-fusing silicone is a lot better than electrical tape. It seals a lot better, and it doesn't leave that sticky residue when you need to cut it off. So I got some of that just in case. But yeah, because of that, I figured, man, it'd be nice to have this corrugated stuff in case I ever forget to put, a nice completed loop onto the wire before I tape it off and make a nice wrapping out of it. So if I weren't so spacey, I'd probably have gotten nicer wrapping, but this will do the job pretty well. When I put it on, on this loom that's sticking out of the car right here, what I did is I took a small zip tie, and every 6 inches I zip tied the wire, flush cut it, and then when I put this on, every 6 inches I'll just do like one little stretch of electrical tape to keep them all in there, and it comes out pretty nice. I think it's not too bad. So Candace is asking me what's been the most challenging task since taking on this car restoration. Most challenging thing has been, the wiring's probably what I've done the most of, and had the most issues with, just because it was all so old and failing all over the place in the car. But was that as challenging as other things? I don't know. It's there's been a lot of custom work that I've had to do. Oh, that's probably it. The oil pan. I had to modify the oil pan, and I had to cut a piece off of it so that it would clear the steering rack, and then weld it back together. Um, and yeah, that was the first time that I'd done something like that. I'm more confident welding thicker materials than really thin stuff. So all of the the small little tack welds I had to make around the whole thing was pretty challenging. And then the more you work the metal, the thinner it gets in that part. So in some of the places it got really thin, and I had to go back and like fill it in and file it and try to make it nice. So yeah, modifying the oil pan is probably the most challenging part of the process. Um, what can I say? Um, yeah, other than what I've already said, you just do your research, take your time with it. If you're building a loom yourself, um, and it's going to take 4 to 10 times longer than you think it is, and that's okay. Just be patient, and it'll come out good. So it's not too terribly challenging, as long as you don't get frustrated with it, and yeah, or unless you wire something really bad and it catches on fire, But that's yeah. Just keep a fire extinguisher handy. Um, yeah, that's yeah. I think that's seeing anything under the hood. I wondered about doing that, but the camera's it's kind of funky. If you could only see it, I wish I had a mirror. It's got like a teleprompter thing on it, and it's plugged into the computer. Um, yeah, it might be a little funky to try to bring that over to the engine bay and show what's going on. I did make a nice aluminum place to mount the relay box, but yeah, this camera's not very mobile right now. Um, I can say that I originally wanted to make a YouTube video about this wiring process, in a bit more organized way, where I go step by step showing you what I have done to solve the problems I've tried to solve and how to wire the relay box together, all that good stuff. But it's just been such a balancing act between the actual mechanic work itself, and then making videos for the project, and then kind of managing the project itself for the open source car, that I thought I would share this as a live piece of entertainment for you guys, education, and see if anyone enjoyed that. If there are any of you watching that would be interested in more detail related to this wiring process, let me know. Post it in the comments, or reach out to me on social media. And if you have any questions you want to ask me. And other than that, I will be seeing you soon with some new content related to the specifications of the open source car and how we arrived at the decisions that we've arrived at as an engineering team. And that's something I'm working on this week, so stay tuned for more content related to that. And until then, enjoy the wrenching and enjoy your wiring, and I will see you guys next time. Thank you. Thanks for tuning in.